Hello, my dear friends. Good evening, all of you. Welcome back to your channel of learning mathematics, class 11. Today we will continue with exercise 9.3. Today we will try to wind up this particular exercise. So there are, I think, around about, mm, 10 questions to be done, so we will try to wind up. There are some big questions also, some important questions are there, some very good questions are also there. As I said, some big questions are also there, important for the board examinations for Nalin Board of School Education. So we'll be trying to solve all those questions today. Okay, so I believe you're all doing fine, you're all ready with your studies. Still some more days are left. Without giving up, please make sure that you do study. As I always say, struggle is always a part of life, never give up. Good evening, all of you. So I hope and I'm sure that now you're getting used to it. All of you, I think you have your pen, paper, book, pencil, scale, everything with you. So without wasting much time, because we have to do a lot of questions today, some big questions also are there, as I said. So I think we should begin. So all right then, shall we? Chalo, number 23. Let's start with question number 23. How's the question states? If the first and the nth terms, of a GP are A and B respectively. Solution. Okay, the first term is A, the nth term is B. So that will be A r power n minus 1 will be B. Okay, we might need that. So let it be as it is. We might need that. And then what we are supposed to prove is, and if P is the product of n terms, okay, P represents the product. P represents the product of n terms. P represents the product of n terms, that is like A1, A2, into A3, into A4, into dot into an. So P represents the product of n terms. So if we just expand this, now geometry progression, we already have been doing 2-3 videos on this, so I believe all of you are getting used to it. So I think I have the right to slightly go a little bit fast. Okay, so let's try. So let's go to A into AR into AR square into AR cube into AR power n minus 1. Now this is what we have. Now with this condition, using this condition, we are supposed to prove that the square of the product P of n terms should be equal to A into B power n. That's what we're supposed to prove. It's not a very big question, so let's try to solve this. So first time I'm rubbing it off. Okay, so A, how many times? A, 1, 2, 3, up to n terms. So A, we have up to n terms. I guess that all of us can understand. R, it's like from 1. So it's like 1 plus 2 plus 3 plus plus n minus 1. Now, A power n. Now this R, we have n minus 1 terms. N minus 1 terms. Let's not forget. A r n minus 1 is equal to B. That's from equation 1. Okay? We might need that, so that's fine. This one, if we just combine all the powers of R, we have 1 plus 2 plus 3 up to n minus 1. That means how many terms do we have? We have n minus 1 terms. 1 term less than n. If you remember, anyway, if you just remember, okay, sum of the first n natural numbers, 1, 2, 3, plus n. Sum of the first n natural numbers, that is using arithmetic progression only again, is nothing but n into, otherwise we can just use that other formula. What was that? If This is an arithmetic progression, isn't it? 1, 2, 3, there are many formulas, many ways in which we can approach this particular formula. So this is already an AP, isn't it? We have the first term as 1, common difference as 1, right? This is not a geometry progression, this term, this sequence, the series, this is an arithmetic progression. So how do we find out the sum of n terms of an AP? The sum of n terms of an AP was, we have two options, n by 2 into a plus l, where a represents the first term, l represents the last term. So we will use that particular concept here. So then in that case, this will be n. But here n value for this particular question, we have how many terms? We have n minus 1 terms for this, because we have one term less for n. So that's going to be n will be replaced by n minus 1. A first term is 1, l last term is n minus 1. So 1 cancels. So we will have n into n minus 1 divided by 2. So that is the power here, using the sum of an arithmetic progression, sum of the series for an arithmetic progression, we have r power n into n minus 1 divided by 2. Okay, now. Alright, so now we will square both sides, because if we look at the proof, we have the p square. So we will be squaring both sides. So we will have a power 2n, r power 2n into n minus 1 divided by 2, because squaring both sides will have 2. Now 2 will cancel, so I'll just rub this off here. Okay, can you do that? Okay, let me just write it down then, divided by 2. So that's going to be p square, a power 2n, I'll just write a n into a n, no problem with that, I guess. And this is r power n into n minus 1. Bas. Now what were we supposed to prove? We were supposed to prove that p square is equal to ab whole power n, wasn't it? We had to prove that p square is equal to, ab whole power n. No problem. So a little bit of adjustment, modification, that is a power n here. Can I write this by, for these two terms, taking n common, I'll have a power ar n minus 1 whole power n. I think that's fine. Just with these two terms, no, this term and this term, I'm taking n as the common power. So in that case, I'll have a r power n minus 1. Because if it comes inside, again it's same, a power n, r power n into n minus 1. I need that proof, that's why I'm trying to approach for the proof. So then, now you look, then that's p square is equal to a power n. Now you see, what is this value? This value from equation 1 is nothing but b whole power n. We can write using equation 1. So then that's our proof. So because you can write p square as ab whole power n. So that's the solution, that's the proof. Alright. Okay then, so those who are done, let's move on to the next question, that is question number 24. Question number 24. I'm rubbing it off, I hope you're done. Chalo. Okay, what is number 24? Show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 to 2nth term is 1 by r power n. A very simple question. We will go directly, nothing much. Ratio is, we have to get this ratio, that is ratio of what? Sum of first n terms. Sum of first n terms to the ratio of sum of n plus 1th term to 2nth terms. We're supposed to prove that this ratio turns out to be 1 by r power n. That means again, In other words, it simply means a1 plus a2 plus a3 plus dot 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 plus an, now up to nth term, is equal to an plus 1 plus an plus 2 plus dot 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 a to nth term. That's what the question says. Very simple. If you can elaborate it, if you can simplify it. So, what will be this? As I said, we've already done geometric progression, those who have been attending regularly. So, I think you can understand. The first term we can write a, no problem. Second term, that is ar. Third term, ar square plus dot dot dot. This is a continuation, ar power n minus 1. If you can just follow the sequence, no? First term ar square dot ar power n minus 1, and it's continuing because it's n and then niche again continuing, n plus 1, n plus 2, double n. So if you just continue this one also, ar square ar power n minus 1. So what will be the next one? If you can just follow arn, because arn plus 1 at term will be ar power n plus 1 at minus 1, because the general term of an arithmetic progression is ar power n minus 1 for the nth term. So what is n here? N plus 1. So n plus 1, so that's going to be ar n plus 1 minus 1. That's ar power n. But sometimes common sense is very much important. So without using all this formulas and all, we just use a little bit of presence of mind, because you see, continuation 1, 2, 3, n plus 1, n plus 2, double n. So that will be ar square, ar n minus 1, an. No, it will continue. It's going. So that's going to be ar power n plus 1 plus ar power n plus 2 plus going 2n, 1 less, that is ar power 2n minus 1. Okay? Alright. Now, if we can do something, what something? Okay. Upper, let's leave it as it is. ar square dot 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 ar power n minus 1. Niche, because if you look at the proof, the ratio is 1 by r power n. That gives you an idea. 1 by r power n. Can we take r power n common? Definitely. R power n, if we take common, what is left here? A. What is left here? R power n is taken common. So 1 power r. One term of r is extra because its r is n plus 1 terms. One term is extra. So if I've taken n terms, only one r will be left. So that's ar. Similarly here, a. r n I've taken out, so I have 2 terms of r left, dot dot dot. Here 1 n is taken out, so then in that case I will be left with n minus 1. Because r power n I'm taking common, so if I take 1 n common, 2n is like n plus n. R power 2n minus 1 is r power n plus 1 n minus 1, isn't it? So if I take r power n common, I'll be left with r power n minus 1. Simple mathematics, arithmetic. So then, you see the proof already there, because these two terms are same. Numerator and denominator. So you have only one left. So that's 1 by r power n. So you see, the question is very simple. It's just about, understanding the question, analyzing the question and cracking the code, because question actually becomes difficult when we don't understand what the question is trying to tell us, because every question, as I say, will give you a condition to solve, to get your solutions, to get your proof. There will be a condition that will be always given to you. You have to try to find that condition. Once you get that condition, you understand the question, then half of the job is done. Okay, so basically, more importantly, you should try to first analyze the question. What is it trying to tell? What is it trying to, trying to tell us to find out, or to prove? That is important. Okay, that's done. 25. Now 25, it states, if A, B, C, D are in GP, A, B, C, D are in geometric progression. That is A, B, C, D are in geometric progression. So if we just assume like R is the common ratio, if R is the common ratio, so in that case, if A, B, C, D are in GP, then in that case, A, this is the first term. B is going to be what? AR. Got it? No, confused. Chalo. Because you see, of course, A is the first term, definitely. And if this is in GP, then in that case, B by A should also be R. So that implies B is equal to AR. Now, another way of understanding it. Similarly, C by B should also be R because it's a geometric progression. That is, C should be equal to BR, and value of B is AR from this condition. So that's going to be AR into R. So that's AR squared. And D by C should also be R. D is equal to CR. C value is AR square into R. So that's again AR cube. Right? Simple as that. Right? Or otherwise, as we have already done in the previous question, if we have 4 or 5 terms, in general, how do you write a geometric progression? We write AR square, AR cube, dot dot dot, first, second, third, fourth. So it's like first, second, third, fourth term. They are in sequence, following a geometric progression. So directly also we can write. Okay. All right. So it's given that these 4 terms are in geometric progression. So from there we get this few conditions. That is, A is of course the first term. B is AR, C is AR square, D is AR cube. Done. Now what they are trying to tell us is prove that A square plus B square plus C square into B square plus C square plus D square, let's say this is the left hand side, is equal to the right hand side. So right hand side also we will solve. Let's first go to the left hand side. Alright, so if it is done, I'm just writing it here so that I can save some space. Okay, so I'll need those values, so I'll just write A, B was AR, C is AR square, and D is AR cube. So I am removing this. So now substitute the values. A square plus B value is AR square plus C value is AR square whole square. Again, BCD. So B value is AR whole square. C value AR square whole square. D value AR cube whole square. So let's simplify this as much as we can, and we'll leave it as it is, and we'll go to the right hand side of the proof also. So there we have A square plus A square R square plus A square R power 4. This is A square R square plus A square R power 4 plus A square R power 6. Done. From here I can take A square common, so that's 1 plus R square plus R power 4 into, from here I can take A square R square common, A square R square common, so that's like 1 plus, so A square R square common, so that's again R square common, that's again R power 4. So then if we just combine, we'll have A square, A power 4, R square, this two are same terms, 1 plus R square plus R power 4 whole square. Our job is not to simplify, our job is just to prove, so let it be. And if we're done with that, we will go to the right hand side. So on the right hand side, we have to prove AB, BC, CD whole square. AB plus BC plus CD whole square. I hope you're done. So now again, let's substitute the values. A, B value, AR. B, AR, C, AR square. C, AR square, D, AR cube, whole square. So that's A square R. We'll have A square R cube. We'll have A square R power 2 plus 3, 5, whole square. Now don't forget this is the whole square. So again from here A square, A square, A square common. But out of the whole square, so another square. Right? R common, but we have a whole square, so R square. So what is left inside the bracket? 1. R square. 1 R out, R power 4, whole square. So that leaves me with A power 4 R square 1 plus R square R4 whole square. Now isn't this equal to LHS? Absolutely yes. So that's our proof. So it's a simple mathematics problem only. Okay, using the properties of geometric progression. Bus. Okay, you can write it down. That's what done. You can get ready with 26. Okay. Question number 26. Insert two numbers between 3 and 81 so that the resulting sequence is a GP. Let G1 and G2 be the two numbers so that, as per the question, what does it say? Insert two numbers between 3 and 81. So we are assuming G1 and G2 to be the two numbers to be inserted between G1, between 3 and 81, so that this 4 terms is a geometric progression. So A is 3. Common ratio, we don't know. But if we can get the common ratio, since we already have the first term, that means now this is the second term, this is the third term, this is the fourth term, because we have 4 terms. So first, second, third, fourth. So if we can just find out the common ratio, then easily we can find out the second term, that is G1. And we can find out this third term, that is G2. So from there, we'll have the 2 missing terms very easily. So very comfortable solution. And nth term, that is the fourth term here is 81. So let's simplify this. That is AR cube is 81. A value is 3 into R cube is 81. I'll solve here. So R cube is 81, cross multiply divided by 3, that's 27. So that's R cube is 27 is 3 cubes. So that implies R is also 3. Then, in that case, what will happen? G1, that's actually what? The second term, so that's like AR, so that's going to be A is 3, R is 3, so G1 is 9. And G2, that's the first, second, third third term, so that's going to be AR squared. So that will be 3 into 3 squared, that is 3 into 9, so that is 27. A very small solution. So our two missing terms are 9 and 27. Again, the concept is, the thing is, you have to understand the question, then it's very easy. Of course, all this requires a lot of practice, but definitely, surely, mathematics without practice, nahi hoga. So a simple question done. Let's move on to, okay, 27. So this is a very interesting question. Again, 27, you can take time to read that particular question. In the meantime, others, you can note down this so that I can rub it off. Find the value of n so that the given term may be the geometric mean between A and B. Find the value of n so that the term that is given to us, a power n plus 1 plus b power n plus 1 divided by a power n plus b power n, is the geometric mean between A and B. Actually, what is the geometric mean between A and B? Geometric mean between A and B is what? What is the geometric mean between A and B? The geometric mean concept I gave you already, so okay, I will not discuss that. In the previous video it's already given. Previous video, in the introduction video, geometric mean concept is already discussed. So the geometric mean between A and B is root over of A into B. What the question is saying is, find the value of n, given that the condition is given, not given, but geometric mean between A and B is given us that particular condition, that is a power n plus 1 plus b power n plus 1 divided by a power n plus b power n. That is, what they are trying to tell is root over of a into b is a power n plus 1, b power n plus 1, a power n plus b power n. We needed a condition to get the value of n. This is the condition that they are giving us. From this condition, we have to solve from this particular given condition and solve and proceed, and with the help of this condition again, find the value of n. Got it? Now, once again, actually we know that the geometric mean between A and B is root over of A into B. But they are also saying that, hold on, wait. The geometric mean between A and B is also this particular value. Okay, so now use this condition and find out or give us the value of n. So we understood the question, we got the equation. Now time to solve. So geometric series part, class 11 mathematics part, finished. Now after that it's about simplification. How you simplify, arithmetic ability will depend on your solution now. So let's try and solve. So let us cross multiply or do something. Yeah, root of a into b, I think I can write it as a power 1 by 2, b power 1 by 2. I think that everybody understands. I think that everybody can manage, right? Because square root of ab is like ab whole power 1 by 2. So I've just reduced one step, that is a power 1 by 2, b power 1 by 2 is equal to a power n plus 1 plus b power n plus 1 divided by a power n plus b power n. Now I'll cross multiply. So by cross multiplying, I'll have a power n plus 1 plus b power n plus 1 is equal to a n b n into a power 1 by 2, b power 1 by 2. Here if we just multiply, multiplication only, this one. So a n a 1 by 2, that's n plus 1 by 2. N plus 1 by 2 into b power 1 by 2 plus, if you multiply the second term, a 1 by 2, b power n plus 1 by 2. Multiplication, simple multiplication. So now, I'll make some arrangements. Like terms of A I'll bring on the, not like, or similar terms of A I'll bring together, and similar terms of B I'm taking it that side. So from here b power n plus 1 goes to the other side. Now, some real mathematics. From these two terms, a power n plus 1 by 2, if I take common. Forget about this term. What is left here? From here, this term is already taken common. I have left with 1 by 2. Similarly, here also bn plus 1 by 2 I'm taking common. So here what have I left? A power 1 by 2 minus. Now, that is not a big problem. What am I trying to do here? I'm trying to find out the value of n with a given condition. So I'm just trying to simplify here, manage something and then try to get the value of n. There can be other ways also, possibly, I believe so. So this, from the second term, a power n plus 1 by 2 is taken out common, so that's not a big deal. Okay, b power 1 by 2 is left. Here also, b power n plus 1 by 2 is common, so a power 1 by 2 is left. That's also not a big problem. What will be left here? Because a power n plus 1 by 2 is taken out. What do we have here? A power n plus 1. What will be left here then, from here? Simple common sense if you apply. Listen. 1. Now from maybe a quantity of 1, okay? From a quantity of 1, if I take half out, listen carefully. From a quantity of 1, from 1, if I take half out, or if I subtract half, or if I remove half, how much is left? Exactly, half is left. Because from 1, if I take half, half is left. If you can just apply that presence of mind, that common sense, I think that will work. Mathematically also we can. There are ways to make you understand through mathematical ways also. But what I mean to say is, from here a power n is also taken common. We have here plus 1. So I'm taking plus half common. So what should be left here? Half, because n is already taken out common. 1 was here. From there I've taken half out. So what am I left? From n plus 1, I have taken n plus half out. So I have only half left. Understood? Otherwise you can, something like n plus 1 can be written as half plus half. So that will be a power n plus half into a power half. So this is taken out common, so this is left for us mathematically. But it's not wasting time solving all that. We can just use our presence of mind also. So similarly from there also, b power n plus 1 is there. I've taken b power n plus half. So what is left? B power half. Now with that what happens is a power half minus b power half, a power half minus b power half. We have the like terms on both sides. So we are left with a power n plus 1 by 2 is equal to b power n plus 1 by 2. Let us cross multiply. Let us bring them together. That is n plus 1 by 2 b power n plus 1 by 2 is equal to 1. Now, we have another concept that is, I'm sure all of you know, any value whose power is 0, anything to the power 0 is how much? Anything to the power 0 is how much? Can somebody tell me? Anything to the power 0, any quantity, whole power 0 is how much? Just to know that you are not sleeping, can somebody tell me the answer to that? Anything to the power 0, any quantity whose power is 0. Let's say 100, let's just say 100 power 0 will be how much? Can somebody please, let me give me the answer to that, so that I'll know that okay, you're watching, you're actively taking part. Exactly, it's 1. Ah, somebody got it wrong. All right, that's all good. No, we have different sorts of answers, so it's all very good. Yes, I'm getting lots of answers here, and most of them are correct. Some, I think, in a hurry, just type the answer. Yes, as I say, presence of mind is very important. So sometimes we should just for a moment think and then only respond, because sometimes that's called carelessness. That's called carelessness. So we should avoid that, especially in mathematics. You get a question, for a moment, think. Is it okay? After that, only once you're confirmed, after that you should go for the solution. So exactly, anything to the power 0 is always 1. I'm going to use that concept now. I'm going to use that concept because I need to find out the value of n. So now, what am I going to do is, I think this is done already. So this, so of course, we have a common power, that is n plus 1 by 2 is equal to 1. I can write as a by b power whole power 0. Okay, some of you for a moment might have just thought that, when did I fast forward? I did not fast forward. No, that was just me bluffing. Okay, I think we can do that, right? So it's a by b power n plus 1 by 2 equal to a by b power 0. Right, there's nothing wrong with your phone. I'm just moving in fast forward mode. Just kidding. Okay, forget about that. I think we can do that, isn't it? Because anything to the power 0 is 1. So just to get the value of n, I think we can do this. Definitely yes. So in that case, a by b whole power n plus 1 by 2, since it was 1, I can write it as a by b whole power 0. So that will be n plus 1 by 2 is equal to 0. So n equal to minus 1 by 2. So n is equal to minus 1 by 2. Okay, so this was a very good question. Let's move on to the next question. Question 28. Question number 28. Okay, another good question here. Very good question. It's very interesting, okay, this particular question. 28. Listen carefully and see. The sum of two numbers is 6 times their geometric mean. Show that the numbers are in the ratio 3 plus 2 root 2 by 3 minus 2 root 2. The sum of two numbers. Which two numbers? Given? Not given. So sometimes that's how we solve or get our solutions also. When you get a question, ask. Given? Not given? Okay, chalo. So that's what it's given here. Sum of two numbers is 6 times the geometric mean. Show that the numbers are in the ratio. Which number? Anybody knows? Do you know? Anybody knows? Which number? Nobody knows. Chalo, so let the two numbers be A and B. Then, let's get the condition. Always. Because we will always have a condition. The sum of two numbers. The sum of the two numbers is 6 times. Is 6 times their geometric mean. 6 times their geometric mean. Because if these are the two numbers, geometric mean means a number that is in between the two numbers. G. So the geometric mean between the two numbers is, as we already know, it's root over of A into B. This is the given condition. Anything else? Nothing else. From here, with this small condition, you are supposed to prove that those two numbers should give you the ratio 3 plus 2 root 2 by 3 minus 2 root 2. That's the question. 3 plus 2 root 2 minus 3 minus 2 root 2. Just with from this small condition. Okay, now now from here, how are we going to get that particular solution? There is always a solution. Now it's up to us on how we solve. Again, geometric progression concept, game up, that's it, finished. Now begins again mathematical abilities. So for this, to solve this particular problem, what we are going to do is we are going to travel back to history. We are going to travel back to history to, I think, 4 or 5 years back. That's class 7, 8. We are going to travel back to history and go to ratio and proportion, where, if you remember, we learned some topics like componendo and dividendo. Such a nice name, isn't it? Componendo and dividendo. Duplicate ratios, sub-duplicate ratios, triplicate ratios, sub-triplicate ratios, ratio and proportion. Some of you must be wondering now, what is this guy talking about here all of a sudden? What is he mentioning? Now, we already studied all these concepts way back in our lower classes. So that's why, to solve this particular question, what we will do is we will travel back to history, to the past, go to the previous classes and bring the concepts of componendo and dividendo. Componendo and dividendo. That is going to help us. Because the concepts of class 11 mathematics finish, no more. We're not going to be needing any more of that concept. Now it's all about simplification, because just from this small condition, we are supposed to get the value of the ratio of the two numbers a by b is equal to 3 plus 2 root 2 by 3 minus 2 root 2. How are we going to do that? Using componendo and dividendo. One of the ways, I mean. Okay? There can be other ways, as I always mention. Now, if you look at the proof, there is a 3, there is 2 root 2, so that is possible, because what we can do is a plus b. 6, I can write it as 3 into 2. No problem with that. None. So let's see how we continue with our solution. Let's begin our solution. 6 I can write as 3 into 2. So now a plus b divided by 2 root of ab. I'm going to cross multiply this. I'm going to bring this down. Arrangement. One more arrangement that I'll do is a plus b divided by 2 root ab. I'll separate. That is root a, root b. 3 by 1. Just for our sake. Not just for ourselves, so that it becomes convenient. Okay? Okay. We still haven't applied. Some of you must be thinking, acha, this is componendo and dividendo. No. This is just cross multiplying and just managing and all, just arranging things and all. We haven't started yet. Now we will apply componendo and dividendo. We are going to apply now componendo and dividendo. Applying, you can write down. I'm a lazy person, I don't want to write, I'm tired also. You write. Apply, you should write. Maybe not in the exams. Examination time, okay, that's not very much necessary to write. But it will be important for you, because when you study, when you're practicing and all, if you don't write, then all of a sudden you'll be wondering like, ye kahan se aaya? From where did this come, this particular step? Something just happens or what? So for your understanding, you should write. Applying componendo and dividendo. I'm lazy, but still I have to write. Componendo and dividendo. Applying componendo and dividendo. Nintendo. Do. Applying componendo and dividendo. Applying componendo and dividendo. Okay? I'm rubbing it off. Now what is this procedure? Okay, flashback. Let's go back to memory. What was componendo and dividendo? Okay, I'll just tell you. I'll tell you once, just once. Suppose you have a fraction x plus y, just one concept, x plus y divided by a plus b. I've already done this, so I'm just telling, I'll be just showing you the procedurally first, okay? So applying componendo and dividendo, what do we do is when we apply componendo and dividendo, what we will do is just a procedure as I mean, quick procedure. What we will do is numerator, I will write numerator, I'm going to write, and I'm going to add and subtract the denominator from the numerator in the fraction. That is numerator. Some of you must be wondering, what? Hold on, I haven't finished yet. So what we will do is numerator you will write down first, okay, in both the fraction, the new fraction, the numerator as well as the denominator. After that, a simple procedure. You will add the denominator in the numerator and you will subtract the denominator in the numerator. This is the procedure, if you remember, for componendo and dividendo. Once again, another example, 4 by 7 for example. So in that case, just an example. In that case, what will we do? Again, what will you do? Numerator, you'll pick up, write down numerator. Okay? And then you will add the denominator in the numerator and niche you will subtract. So numerator plus denominator, numerator minus denominator. That's called componendo and dividendo. Okay, so we are going to apply that procedure now. And remember, we don't work on one leg, isn't it? It's not that we get tired, so one leg we keep at home and then we just walk with the other leg. The other leg takes a rest. No. What I mean is, you apply componendo and dividendo here, you have to apply componendo and dividendo here also. Don't just apply it here and leave it. Understood, no? Okay. So now, as I said, let's start the procedure. So that's a plus b. So adding the denominator, subtracting the denominator with b. Here also numerator, adding, subtracting the denominator. Got it? Now let's simplify. Some arrangement again. I have a 2, if you remember the formula, a plus b whole square. A square plus twice ab plus b square. A minus b whole square, a square minus twice ab plus b square. Somewhat similar to that, root twice of ab, root. So I think we can make some arrangement. I think we can write, no problem, I believe. I guess you are. Oh, this is class 12, 11 standard, so I don't have to really go into detail. Many things you will understand. These are basic arithmetic, so that's why I was telling you, there's after that particular first condition, there is no more class level mathematics. It's just about now going back to history and going back to the past and solving. 2 1 2 2 to the 4. This one I think we can write a plus b whole square, because it's like a square plus b square plus twice ab. Now similarly niche, so I have a square, I'll take the square root on the other side, I'll be left with removing the square. No? Okay? Okay, so again, some of you must be wondering what, when we were about to find out a by b and then this guy has brought again root over of this and that. Hold on, as I said, I'm not done yet. Have some patience. We are almost there, because, write down again, applying componendo and dividendo. Again, one more time. Applying componendo and dividendo. One more times. So applying componendo and dividendo one more times. Don't write that. Just write applying componendo and dividendo. So again, if you apply componendo and dividendo, what will we have? Numerator. Add the denominator. Subtract the denominator. Subtract means negative value should come, bracket should come. Addition, no problem. Subtraction, that negative value, after the negative value, the bracket should come so that you don't make any careless mistakes. Bujings. Plus b plus b. So 2 root of a divided by root of a plus root of b minus root of a plus root of b is equal to root of 2 plus 1 root of 2 minus 1 a. So we have 2 root of a, 2 root of b is equal to root over of 2 plus 1 root over of 2 minus 1. Now 2 cancels. Now I'll square both sides. Because if I square both sides, I get a by b on one side. So on the other side, I think it should take care of itself. Root 2 square is 2 plus 2 root 2 plus 1. 2 minus 2 root 2 plus 1. So a by b is equal to 3 plus 2 root 2. 3 minus 2 root 2. Tell me we don't have the answer. Yeah, we have the answer, isn't it? We have the solution. Yes. So now if you take a moment to go through that solution right from the beginning, you will see that we haven't really applied anything that belongs to class 11 mathematics except that first line. The rest have been all what? Basic arithmetic. 4 by 7 is equal to 4 plus 7 divided by 4 minus 7. That implies alright, so bus, that's it, that's our solution. Okay, let's go to the next question again. Another question is there. Now, most of the students, when they look at especially this particular question number 29, no? The moment they look at the question, ho gaya kaam khatam. What kind of a question is this? Who is going to really understand this particular question? Well, hold on, at least have a look at the question. You will see how simple it is. As I said, it's all about understanding the particular question. Once you understand, it's very easy. The problem is always that we are not able to really understand the question, the conditions given in the question. That's one of our main problems. Let's try. 29, it says, if A and G be the arithmetic mean and geometric mean respectively between two positive numbers. Which positive numbers? Nobody knows. So what do? Let the positive numbers be A and B. Let the positive numbers be A and B. Okay. So as they say, A is the arithmetic mean between two numbers. So that's going to be like A plus B by 2. G represents the geometric mean between two numbers. Okay, that's root of A into B. These are all the conditions. So we're just trying to just take out all the conditions that is given in the question. After that only we will go for solution. If A and G be the arithmetic mean and geometric mean respectively between two positive numbers, okay, that's already decided what is mean. Prove that the numbers are A plus or minus root over of A plus G, A minus G. Remember, what does A represent? The arithmetic mean and the geometric mean. Fine, that's understood. Okay. What is the question also saying? Prove that the numbers are, what numbers? A and B are A plus or minus, that is A plus, that means one of the number is A plus root over of A plus G, A minus G, and the other number is A minus root over of A plus G, A minus G. Okay, now what does this really mean? It simply means that, listen, it simply means that you have two positive numbers. We have assumed it to be A and B, can be anything else. We have assumed it to be A and B, fine. And A, capital A and G represents the arithmetic mean and geometric mean. Okay, understood. What they are telling you is that whatever numbers you choose, you are supposed to see to it that those numbers are actually these two values in the hidden form, something like that I would say. That means if you solve this, you will be either getting A. If you solve this, you might be getting B. That's what it means. That means those two numbers are these two actually in the hidden form. Now, because we have assumed the numbers to be A and B, the question is also saying that if A, they haven't given us the numbers, so we are assuming it to be A and B. Fine. Capital A and G represents the arithmetic mean and geometric mean. So here this represents the arithmetic mean, the geometric means. And this is an equation, fine, understood. What are we supposed to prove is, using these conditions, we are supposed to prove that the two numbers that we assumed are nothing but these two. That means A and B is hidden either here or here. Most probably this might be A and this might be B. So we're just supposed to solve this. If we're able to solve and prove this value to be A, solve this and prove this value to be B, then these are our two numbers, A and B. So that's our proof. That's our job done. It can be anyone. This might be B also. This might be A also. We do not know. So we will check and see and prove that yes, this is really A and B. Why only A and B? Why not X and Y? Why not? Definitely, surely. You can use this as X and Y. So in that case, it will be X plus Y divided by 2. This will be root over of X into Y. Okay? Now we are supposed to get the two numbers from this given condition. A plus G, A minus G. Let's solve this. A is this value, plus or minus root over of A plus B by 2 minus root over of AB. A plus B by 2 minus root over of AB. Just substituting the values of A and G. Now, just a moment, let's not complicate, this is too big again. Let me make it easier for you, because this one can also be written as A square minus G square. No? Let's just reduce one step. No? That will be easier. So that is going to be A plus B divided by 2 plus or minus root over of A square. That is A plus B divided by 2 whole square minus G square root of AB whole square. Let's solve this. So that's A plus B divided by 2 plus or minus, simplify. That's like A square plus twice AB plus B square divided by 4 minus AB. AB by, let's say, 1. This is just about simplification. Plus or minus. Taking the common LCM for A square plus twice AB plus B square minus 4AB. So that's a plus b divided by 2. From where is this 4 coming? Plus or minus? This is nothing but a square minus twice ab plus b square divided by 4. So this is also a plus b divided by 2 plus or minus root over of this can be plus a minus b whole square divided by 4. So that is a plus b divided by 2 plus or minus a minus b divided by 2. So this implies one number is a plus b by 2 plus a minus b by 2, and the other number is a plus b by 2 minus a minus b by 2, because it's plus or minus. So that's like 2 a plus b plus a minus b. This one again 2 a plus b minus a plus b. So if you just simplify, solve this further, what do we have? B cancel, we have 2a by 2. You see, we get the number back again. And those two numbers, a cancels, this is again 2b by 2, so here also b. That means those two numbers that we assumed were actually hidden in the given equation. So ultimately we also get, if we have assumed the two numbers to be a and b, those two numbers are what? As given in the condition, a plus minus, that will solve. Those two numbers were a and b actually. Okay, so this is what the question suggests. Okay, so finally the big questions are almost done. Let's quickly move on to question number 30. Simple question. The number of bacteria in a certain culture doubles every hour. If there were 30 bacteria present in the culture originally, I hope you're not falling asleep. Just two more questions. Let's quickly do it. Even I'm also tired, so let's quickly finish it. The number of bacteria in a certain culture doubles every hour. If there were 30 bacteria present in the culture originally, starting 30. Since the bacteria doubles itself every hour, the sequence is given by, so it doubles every hour, so sequence starting from 30, next double 60, next double 120, next double 240. This is going to be a sequence because every hour it's going to be doubling. So this is the 0th hour, not initial. After 1 hour, 60. That's the first hour. Don't confuse. First hour doesn't mean one. First one. No. Initial. 0th hour. That's from where we begin. Time is 0. So initial. Initial starting. Okay, 30 there. Start. So go. After 1 hour, how much? 60. After 1 hour. So that's like A2. Second term. And after 2 hours, 120. So don't be confused because most of the times students, they confuse. First hour, okay, that's 30. No, this is not after the first hour. First hour is 60. After 1 hour, 30 is like, okay, here we start. Initial, 0, 30. After that, we wait for 1 hour. And then see, it's 60. So don't confuse that. Only that confusion should not be there. How many bacteria will be present? So anyway, this is the sequence. So our first term is 30. Common ratio, since it's doubling, definitely 60 by 30, of course that's 2, no problem. So now how many bacteria will be present at the end of second hour? How many bacteria will be present at the end of second hour? bacteria present at the end of second hour. So this will be A2 or A3? Second hour. Tell me, this will be A2 or A3? Again, so that I know that you are not sleeping. Second hour. Second hour will represent the third term or a second term? Again, time for you to respond, my dear lovely students. Bacteria present at the end of second hour. Second hour. So yes, exactly, third term, A3. Perfect. Because just now as I said, what did I say? After 1 hour, after 2 hours, after 3 hours. So that goes as A0, A1, A2, A3, something like that. Okay, this is the first term. After 1 hour, after 2 hours, after 3 hours, something like that. Okay. So at the end of second hour, that's going to be 3. At the end of second hour. So first hour, second hour. I mean, this is the first hour, this is the second hour. So what am I doing then? 0th hour, right? First hour, second hour. So second hour is first term, second term, third term. So that's 8r squared. So what was the value of A? 30. R was 2 squared. So like 30 into 2 to the 4. So that's like 120. Again, 4th hour. So I'll just write down here. Okay, bacteria present at the end of second hour. Next is, I don't want to write again. 4th hour. 4th hour. That is like first hour. This is 0th hour, first hour, second hour, third hour, 4th hour. So 1, 2, 3, 4, 5. A5 is A r power 4. So that's going to be 30 to power 4. So like 30 into 2 to the 4, 4 to the 8, 8 to the 16. So that's like 480. 480. And then finally, nth hour. So nth hour will represent, remember, nth hour will represent n plus 1, because all of these hours you see it's one term extra. After one term, it's a fifth term, one term extra. So if it's about nth hour, then definitely it's going to be what? N plus 1. Again, here don't confuse. Alright? Because we are always having moving one step ahead, isn't it? 4th hour means the fifth term. Second hour means the third term. So nth hour means n plus 1th term. So that's going to be a r power n plus 1 minus 1, because this is n minus 1. So that's like 30 to power n plus 1 minus 1. So that's like 30 to power n. 30 to power n. Okay? Alright, let's move on to the next question. Quickly, almost done. Almost there. 31. What will 500 amount to in 10 years after it deposits in a bank which pays annual interest at a rate of 10% compounded annually? Okay, principle. $500. Do you still remember? Rupees 500. I'm not writing that 500 and all. Do you remember principal, simple interest, amount, PRT divided by 100 is a simple interest. If you remember, simple interest formula, PRT by 100. Amount is principal plus simple interest. If you remember those formulas, we're again going to be needing those formulas again. What will rupees 500 amount in 10 years? We have no idea. After it's deposited in a bank which pays annual interest of 10% compounded annually. Annual interest, rate of interest 10% compounded annually. So what will be the interest after first year? Interest after first year. What will be the interest after first year? Or interest not after first year, like let's say interest in 1 year. So what will be the interest in 1 year? Let's find out. What will be the interest in 1 year? Interest in 1 year, let's say I. will be P R T times 1 year, huh? By 100. 1, 2, 1, 2. So that's like 50. So what will be the amount that you will have to pay after 1 year? Amount after 1 year. So that's going to be 500 plus the 50 rupees extra. So you'll have to pay 550 rupees. I think that's all that we need. That means the first term is 500. That's from where we start. And then the interest goes on and on and on. So second year we are supposed to pay 550. So like that we are supposed to calculate, and then at the end of 10 years how much are we finally paying. So that's like a geometric progression or a geometric series. So what we will do is, okay, we already have the first term, that is 500. Common ratio will be second term divided by the first term. So that will be 11 by 10. So that's going to be 1.1. Okay, so common ratio will be 1.1. Simple questions. So now the ultimate question is, what will be the amount after 10 years? So that's like amount after 10 years. After 10 years. So similar to that previous question, after 10 years. After 10 years means 11th term. Don't forget that, because after 1 year means the second term. Last question also the same concept. Okay, so that's like A11. So that's like AR power 10. So A is 500, R is 1.14 power 10. Let it be. Okay, chalo, finally, after such a long wait, the last question of this huge, humongous exercise. 32. Miscellaneous also, there are many problems again. 32. Let's have a look at the question number 32. If AM, arithmetic mean and geometric mean of roots of a quadratic equation are 8 and 5. Quadratic equation, again going back to basic concepts. Quadratic equation will have how many roots? Quadratic equation is always of the form ax square plus bx plus c equal to 0, if you remember. And here, of course, generally we have two roots. We name it as alpha and beta. That's up to us what we name, alpha, beta, gamma, sigma, whatever be it. If we happen to know the roots, if you remember, if we happen to know the roots, then there is a way to find out the quadratic equation, because the question says, if arithmetic mean and geometric mean of roots of a quadratic equation are 8 and 5. So just the arithmetic mean and geometric mean of the roots of a quadratic equation. What are the roots? We don't know. Then obtain the quadratic equation. Now to obtain the quadratic equation, either we know the roots, either we get the roots. After that, we can get the quadratic equation. If we cannot get the roots, then there is another way. If you remember, what was that? It was x square minus sum of the roots plus product of the roots will give us the quadratic equation. Remember, you see, all these basic concepts are required to solve mathematics. That's why we always shout and scream. Concepts are so much important. That means without the concept of a quadratic equation, there is possibly no way you will understand how to solve this particular question. You will have no idea what is going to happen, how are you going to do it. So what we are going to do here is, we are supposed to obtain the quadratic equation, but neither the roots are given, neither the sum of the roots and product of the roots of the quadratic equation are given. So how are we supposed to find? Exactly for that reason, there is this condition given that arithmetic mean and geometric mean of roots of a quadratic equation are 8 and 5. Must be for a reason. Let's see. So for that, what we will assume is let A and B be the roots of the quadratic equation. Now what the question is telling us is that arithmetic mean of the roots of a quadratic equation. What are the roots? A and B. So what they're saying is the arithmetic mean of the roots of quadratic equation, that is of A and B, is how much? 8. That means A plus B divided by 2 is equal to 8. A plus B is equal to 16. Tan, tan, tan. You see? What are A and B? The roots. A plus B, sum of the roots, you see? So that means we already have the sum of the roots. Interesting question, isn't it? Another thing that is given to us is and geometric mean of A and B. That is also given. How much is it? 5. That is root over of A into B is 5. That means square root of A square is B. What do we have? A into B. A into B is also what? Product of the roots. Because what are A and B? The roots of the quadratic equation. So don't we have it here? Sum of the roots 16, product of the roots 25. Done? I'm rubbing that part off. That's it. That's your quadratic equation that you wanted. So that finally sums up the exercise. Such a big exercise, 9.3. I'm surprised that we could really finish it. After that, you have just one small exercise that's about to find out the sum of it. I mean, up to infinity, sum of terms to infinite, up to infinity. So that's not very difficult. And the last exercise, of course, is being reduced for your batch, this particular batch. So this exercise, this chapter will be done very soon, and after that, if the cooperation continues like this, then most probably I think next topic we might start something like conic sections. That's a very interesting part. Circles, all these conic sections. So it's been a long class today. Thank you all. Most of you have been so patient, so nice. Thank you so much. Okay, thank you so much for being with me in the classroom, trying to learn, because as I always say, without you, the whole class is meaningless. It's all meant for you only. So the sacrifice that we put in, it's worth. Sometimes we do certain good things for others, but sometimes the satisfaction is not there. But when people are, enjoying what you're doing, then it gives me utmost satisfaction also. So thank you all for being a part of this class. A big exercise finished, all because of your support. Thank you, each and every one of you. Romson and some other names also. Ashter, every afterlife or something like that. Yeah, all of you, thank you so much, and a very good night to all of you. A very good night to all of you. Man, thank you. Send also, thank you each and every one of you. And yeah, a very good night to all of you. Pleasant hours, everybody. Nasibanla, Imli Maran, Chubajongla, Imli Mongla. The other nickname is like Rain. So each and every one of you, thank you. A very good night to all of you. Rest well, study well, prepare well. Yes, don't forget to stay safe. Okay, see you then. Till then, bye bye. Good night.